Hello student, today I am going to teach you the realization of the LC network. In previous lecture you have seen all about the synthesizing of the network circuit, in which we have studied the how do you find out the H polynomials, and further we have taken some example to how to understand the H polynomial and find out the solution of that, so complete solution of that. Now in this lecture we have realization of the LC network. There are four basic method of the realization of the network. So by the name of the scientist, it would be Foster 1, Foster 2, Cursor 1 and the Cursor 2. So in your curriculum these four types of uh, realization you must be studying in the coming slides. So let's go and check one by one. Now this is the Foster realization. See, Foster relations means once we have studies in the Foster relation was the general equation of the general equation of the this is the general equation. This is the very general equation. Yeah, this is the general equation. This is the general equation of the network. General equation. This is the very general equation. I have told you the earlier. This is the general equation. So if we write the equation, if we write the function in terms of equation, then it would be fs is equal to h s square plus omega square, omega 1, and here is the omega 3, here is omega 2, here is omega 4. So this is the whole and this is the 0 of the network I have told earlier. And if we find in the terms of network, so in the term of function we have write then fs is equal to p by q along with x, along with the function s, along with the function s. So you might be familiar with this equation, and this is the equation of the this Foster relation. Now what we have to do, find out, we have to separate by division from this equation. We have to separate impedance, like we have to separate impedance and take some partial fraction, the basic partial fraction, and after that we combining these conjugate poles and find out the solution. So this is the after combining the conjugate poles, this is the this is the method in which we have to study. So let's go one by one. First of all I would like to remove all this. Now see, in this Foster 1, this two kind of Foster 1 and the Foster 2 theorem is there. So by dividing on this general equation, we have to find out ZS means we have to replace this function fs is equal to ZS, and after taking partial fraction, combination of this partial fraction like this, it would be k0 after combining the conjugate. If you first of all in step first, you first of all find out the partial fraction of the given equation. See, this is the partial fraction. What you have to do, just take the partial fraction, right? So this is after taking the partial fraction, it would become like this, and combination of the conjugate poles and write this equation. Then k0s, this is 2 kgx s square, and So this is the combination of the conjugate. See, then it will become like this. So this is a simple mathematics you have learned about your third semester or in the 12th class examination in curriculum. Now, after showing this, after completing this equation, what you have to find out? You have to find out the impedance Z. So how do you find out the Z? So take this equation, take it right over here, and once I have said, I have mentioned here Z. Just look at that. This is for your convenient. ZS. If I take ZS, ZS means this one, and this one is nothing but, if you remember, if you solve this equation, this is nothing but B0 divided by, if you remember, if you solve this equation, then it will, by this equation, as I have written that A0, I'm coming this later and coordinate with this equation. Once I have realize this equation, A0 is the function, A0, right, plus 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 Z to S, right, Z to S, Z to S, right. So this impedance equation is come from this general equation. While you are solving and find out the partial fraction, then this equation come to the, so this is the general equation. This is the general equation. If I put in the term of ZS, then how are you like that written that, then it become K0 by S, K0 by S, and impedance Z1 K0 S is equal to, sorry, just a minute, and this is become to Z1S. If I written in terms of equation, Z1S is equal to K0S, right, K0S. And how do you define the Z1S? How do you define the Z1S? How do you define the Z1S? So if we define the Z1S, then Z1 is nothing but 1 over capacitor connected in parallel with the network. I have remember you. I would like to tell you that this is nothing but the equation of the parallel capacitor connected in the network. So this impedance is written over here, 1 by C by S is equal to some constant divided by S. While we are solving, then the total value of the capacitor is like this. Understand? So this is the way you have to find out the value of the capacitor, and similarly like this you have find out the value of the L. So by using this simple equation, general equation. Now let's move from the another slide. And so once we have find out the equation, equation for the inductor and the capacitor which is connected in the network, simply you have to remember the inductance in terms of S domain is written like this, and the capacitor which is connected parallel in the network is like this. So these are the basically written way we have to written in the equation terms. So this is all about the so I have mentioned here also this L by C, and this is the value we have to return. If I take in the tabular form, this would be like this. So inductor, this is 1, this is 0.2. So inductor is written like this in the network, and capacitor in like this. So this is the value of impedance. This is the value of impedance. Impedance is denoted by Z. If I written in form of admittance, then we have to find written like this. So this is nothing but the admittance. This is nothing but like the admittance. So these are the concept you must know about how we would like to written in form of admittance and the impedance while the components L and C is connected in the network. So I hope you all of understand the concept of the admittance and the some impedance of the network, LC network, which synthesize while we are synthesizing the network. So how do you find out this impedance? So simple formula, 1 by S. This is the LC L term, and this is the C term. Connect there and solve this problem. You would like to find out after solving this is the equation you have to find out now. So the value of Ci is equal to 1 over 2i, where I is some constant, Ki is some constant, and find out this. After solving this, the total value of inductor which is connected in the network is 2Ki divided by omega 1. So impedance function, while we are taking the impedance function, so impedance function is I have already told you K0S by 1 by C in the tabular form, which I have written in the further. See, this is the tabular form, and after solving this equation impedance function, you have to find out C is equal to 1 by K0. Now similarly, we have to find out the inductor and capacitor which is connected in the parallel, and we have to find out this by this simple equation. By simple equation, put it the value of Ki, which we have already find out in this equation. See, this is the value of Ci, 2Ki, Li is equal to 2Ki. We have find out. Now these two values are put it over here. Then find out the value of inductor and the capacitor, which is like this. Now similarly, in this equation we have to find out in the case of admittance, and we have to find out 1 by C and 1 by LCI and find out this value. So this would become like that. Now if we realize this network, when we realize this network in the real term, then we have to put this like the value of capacitor C, then the value of this impedance, this is the value of Li, this is the value of L2, so and this is the capacitor value, of course. So this type of synthesizing of network, you have connected n number of network over here, and ultimately the inductance is written Ln. So these are the steps. So we have learned about the posture 1, in which we have studies how to impedance and admittance calculate and put it on over the network. So these are the conditions. These are the basically terms of finding out the or you can say that the synthesizing of the network in LC network in the network which is placed in the large type of network. So today I am going to stop my lecture here. Goodbye.